So, welcome for 1.2, measuring segments and midpoint. The goal of this is to be able to use properties of segments and midpoints to find segment lengths. This lesson is a basic beginning for geometry, but it's an important concept because it teaches us several things like modeling and thinking and all of this stuff that I'm going to try to get you to do this year, using your algebra skills to solve problems. Okay, this first thing, it's a bell ringer for class, and we've already talked about it in class, so I'm going to talk about it further on the video. It says, what are some methods for finding the distances between points A and B? Several of my students told me that they counted like this to come up with 8, so counting, that's a method. But what if the numbers are so far apart that it would take you 2 or 3 days to count how far they are apart? We don't want to spend that kind of time when we have a math method. And one of my students talked about the fact that he moved A to 0 because that's its absolute value. It's 3 spaces away. Then he added the 5, which B is 5 spaces away. So when he performed that, 3 plus 5, he used a method of absolute value. If you remember, an absolute value is just a number's distance from 0 on the number line. That's all it is. How far is it from 0? Okay, so I can take any 2 points, and I'm going to call them point A and point B. If I subtract them inside that absolute value sign, okay? So let's do it. Let's look at it. A was at -3 minus, where's B? Over here at 5. Now I'm going to solve in here first. What's -3 minus 5 gives me -8. What's the absolute value of -8? 8. Because that's a distance. And here's an important note. Distance. Always positive. Always. You cannot have a negative distance. You can have a negative direction up here from 0. I can go toward the negative direction. But every one of those numbers still has a distance from 0. And distance is always positive. So this is how you find the distance between 2 points on a number line. With that said, if you're at home watching this video, pause your video, use this method I just gave you, and try to work example 1. If you use that model here, A minus B, then here you would have done C minus D to find that 1 minus 4 is -3, and the absolute value of that is 3. A little note here, to learn to communicate precisely, think about how notation and symbols are used. How might the notation for a segment and for the length of a segment help you remember their meaning? So, this says, how can you find the length of line segment CD? That's the way that's written with that little symbol up there. Don't forget that we use those symbols and what they mean. Okay, next, flip that to the back of that page. If you're at home, you can print these papers. If you can't get them printed, you can send somebody up here to get them. I've got them in my room. So this says, refer to the figure shown. How can you find the length of AC? A to C. So using that same model we had earlier, you try this problem. Pause your video and try that problem. So, with the same model in mind, I'm going to take the absolute value of A minus C. So A is at -3. and C is at 1. So negative 3 minus 1 is negative 4, and the absolute value of that is 4. Now, that's the mathematical way to do that. When you're asked to do all these others, some of these have more efficient ways. Just like, how far is it from B to C? 1. And how about C to D? 3. B to D? 4. A all the way to D. Let's do that one. A minus D. So I've got negative 3 minus 4 absolute value negative 7, which is 7. And A to B, well, B's at 0, A's at negative 3, so that has a space of 3. So I don't care, personally, how you do it, as long as you remember that when the numbers are too hard to just look and see, that you can remember to take away the absolute value of the two numbers. Subtract them and take the absolute value. Okay, moving on. I'm going to talk to you about the first postulate that we have. And I want to define what the word postulate means. It is a rule. I can't seem to write today, but it's a rule. A postulate says, this is the way it is. There's no arguing with it. There's no exception to it. It's the way it is every time. This is our first postulate, and it's called the ruler postulate. And it says that every point on a line can be paired with a unique real number. This number is called the coordinate of the point. So, X here is at 3, and Y is over at 7 on this ruler. That's their coordinate on this line, 3 and 7. Now, with that said, I found out this morning in a class that you guys may or may not know how to read a ruler. Tape measure. So, I want to stop right here for just a second, and I want you all to draw a big old line right there on that area of your paper. And I want you to number this end 0 and this end 1. And then I'm just going to show you what the divisions are down to a 16th on this between 0 and 1. So right in the middle is 1/2. Any problems with that? 1/2. Right in the middle of that is 1/4. In the middle of 1/2 and the whole number 1 is 3/4. So I've just done the fourths and I've done a half. How many halves are in one whole? 2 halves. Those are equal. How many fourths are in a half? 2/4. That's the same as a half. Those are equal. So if I say, how many fourths are contained in 2 inches? We didn't write that one. 4/4 in 1 inch. So if I say how many fourths are contained in 2 inches, you know that 4 is in 1 inch. 2 times 4 is 8. So there's 8/4 in 2 inches. Little tidbit. So, I'm just going to keep dividing stuff. Let's make the mark in between every one of those marks. So if this is a fourth, this is 1/8. Half of a fourth is 1/8. So if that's 1/8, this one is 2/8. And then 3/8. And a half would be 4/8. then we're to 5/8. And the 3/4 is at 6/8. And then 7/8. And 1/2 would be 8/8. 8/8. The only other division here is to get halfway between each of those marks. And I'm going to write above this because it gets a little crowded if I don't. So if this is an 8th, half of 1/8 is 1/16. And then that one is 2/16. 1/8 and 2/16 are the same fraction. 3/16, 4/16, 5/16, 6/16. See how this is going? 7/16. And then if I get to a half, I should have 8/16. Because what's half of 16? 8. And it just keeps going. 9/16. I know. You're going to run out of room. Don't flip out about it. I'm going to give this out in a couple of weeks when we do a couple of measurements, real-time measurements. I'm going to give you a little gauge. But I wanted to go over this because a lot of people just don't understand how that ruler between the two numbers is busted up. The smaller the denominator, yeah, the smaller the piece, the larger the denominator. So that's typical. Now, most tape measures go to 30 seconds, right? And I'm not even going to try to write those on here, but if you just went through here, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 30 seconds. The smaller the pieces are, the larger the denominator. Okay. So, back down here, this just helps us confirm that we were doing it right with the distance on a line. It's the same thing we talked about. If I want to find the distance between x and y, then I can either subtract x from y and take the absolute value, or I can say y minus x. I'm going to get the same answer both times. Doesn't matter which one I start with. Okay. Next page of your notes, please, says example 2. Find the length of a segment. And then there is another example at the bottom here that uses different numbers. So I want you to pause your video and try this page on your own. Come back and check your work. Okay, so after you've tried these two problems, here's the answer. The first problem is 4. Remember that there was a couple of ways to do it. Doesn't matter what you subtract from what, as long as you're taking the absolute value. And then this problem at the bottom had two different problems in it, JK and KM. Must be an M, KM. So you should have got 7 and 15 on that bottom problem. Alright, rolling on to the main part of this lesson. And I don't want to say hard part, I just want to say main part. We're going to talk about the segment addition down here. But before we do, we're going to look at these little examples up here. And I want to make sure that you can read this. It says, if points A, B, and C are on the same line, with B between A and C. So that's what that looks like in picture. A, B, and C are on the same line, and B's between A and C. You might have to draw that. It may just be words in a problem, okay? And you might have to draw it. But this is the segment addition postulate. It says, if you've got this situation going on where you got 3 points on the line, then A plus B, we're going to underline that, circle that in yellow. this little piece right here plus BC, we'll do that one in blue, this little piece right here are equal to AC. Where's AC? That whole thing. Now, I hope that makes sense to you, to say if I take this little part plus this little part, that I get the whole thing. That'd be like saying, what's the final score of the basketball game? Oh, I don't know. At halftime, it was 27. That's the final score, though, right? Got to add the two halves together to get the final score. So, same thing here. I'm going to model that. You've got A, B, and C on this line. Here's AB. Says it's 8.22. And here's BC at 4.70. I think that's a 6. Sorry, they use decimals here. And that, if you add those together, it equals AC, which is the whole thing, which says that it's 13. You can check that math. We can do it right here. So we've got AB, which is 5. That's this part. Plus BC, which is 5. That's that part. And it equals the whole thing, A to C, which is 10. This is called the segment addition postulate. And when there's just numbers involved, it's pretty simple. What gets kids more than anything, I think, is when they start throwing variables into the problem. Oh, I colored that wrong. That should have been blue. Because yellow and blue in my life make green. I try to keep things tied into the rainbow when I use colors. If I'm adding two things together, I'm going to get this plus this gives me that green. Yellow plus blue gives me green. Okay, so here we go with our first example problem. This is going to be a I do and explain problem. And then you're going to try a couple. So it says F, G, and H are collinear. They sure are. They're on the same line. Now, using what I learned up here, I should know that this little piece right here, F to G, plus this piece of the line over here, G to H, add together to give me F all the way over to H. So, that was given information. This is given. It says if G to H is 16. So, from right here to right here, that is equal to 16. What is FH? F all the way to H. I got to find a few things here. Okay? I can't just look at that and say, oh, that's 16, so this has got to be about 3, and I'm going to say it's 19. That'd be a good guess, wouldn't it? Would you go with that? Would you say that if this is 16, that's about 3 or 4? So the answer is going to be 19 or 20. We got to go with the math that's here. What is that 16 equal to? That 16 is equal to that expression, 2x plus 2. So now I can solve this for x, and I find that x is equal to 7. Great. Gets me nowhere near that yet. Nowhere near answering this big old question out here. But gets me closer to finding this piece, don't it? Because I can say that FG is equal to 3x minus 1. And if x is 7, I can plug that bad boy in there for x. What is 3 times 7 is 21 minus 1 tells me that F to G right here is 20. Oh, come on, Miss Burns. Ain't no way that's 20 and this is 16. Does it even look like it would be 20? Okay, well, here's where you learn an important lesson. Not drawn to scale. Do not let that picture mess you up. Trust yourself enough to remember what you're doing. Try to stay on track here. Trust yourself enough to do this problem and understand that just because it doesn't look like it's 20 doesn't mean it's not 20. But now, how do I find F to H? Have I answered that question yet? No. Well, what's F to H equal to? F to H is the green part over here, right? It's equal to F to G plus G to H. The F to G was the yellow segment, and the G to H is the little blue segment, the long blue segment. Everybody okay with that? So, effectively what I'm doing here is modeling using line segments and color. That's something you need to get comfortable with in geometry. You're going to have to draw things. You're going to have to model situations, because when it gets really complex, you're going to need some way to keep track of what you're doing. And this is the best way. Modeling with color, modeling with an equation that uses the names of the parts. So, I'm looking for F to H. That's my unknown value. I know that F to G is 20. And I know that G to H is 16 because that was given to me. So what's F to H equal to? A whopping 36. Ladies and gentlemen, that is segment addition postulate. The segment addition postulate says if I take the two parts, it equals the whole thing. But I don't want you to get carried away and think that it doesn't mean there could be more than two parts, because there could be multiple parts. Could be 3 or 4 pieces, and they want the whole thing. Okay? So you just take the pieces and add them up. They equal the whole line segment. So, pause your video and give these problems right here a try. See how you do. Take your time. Don't get carried away. And then come back for the answers. Okay, so after you try this problem, I'll point out a few things about modeling again. I want to talk to you about that pretty heavy because I need you to get in your brain that you are capable of setting these problems up on your own. And when you model things with color and or model the equation like this, you wouldn't even have to write all these letters out. You could have just used a yellow dot plus a blue dot if you colored in the problem to model and pull the given information. So the answer here was you had to find n, which was 4, and then you had to plug that back in to each section to find. How do I check? Well, this yellow piece plus this blue piece, yellow piece plus the blue piece, I can't even talk, 12 plus 13 should have equaled the whole thing at 25 because that was given in the problem. See down here, a little more complex because it had binomial expressions for each segment, but it was the same concept. If you model this with color or writing, whichever one you need to do, then what you wind up with is an easy setup on this problem. But the final thing said, what is LM? And LM was our blue section over here. So we had to pull back out our expression and plug our x value into it 99.999,000 times percent of the time. That's almost always. You're going to have to find the value of the variable before you can answer the question to a geometry question. That's life in geometry land. And I showed my work down here in Mathtopia. This would be considered perfection. I do not expect yours to be as neat or perfect, but you should strive for it to be neat and perfect, okay? Your assignment with this lesson is 1.2, measuring segments and midpoint practice. Now, stops right there. This is just about measuring segments. We're not using the midpoint yet in these problems. That's our next lesson. Good luck.